Assalamualaikum and selamat sejahtera. My name is Muhammad Aziz bin Abdul Latif. We are from Group 4. This is our subject BMMH 2313 Fluid Mechanics. Okay, our topic that we want to talk about today is pressure in pipe. Alright, this is our group members. Number 1, we have Muhammad Qayyum bin Suhaimi, matric number B0920100349. And number 2, we have Muhammad Hazim Aiman bin Hazman, matric number B0920101111. And number 3, which is me, Muhammad Haziq bin Abdul Latif, matric number B0920103335. And last but not least, we have Sri Vishnu anak lelaki Jaisilan, matric number B0920100406.
Okay. First. Ini.
Nanti semua kena pakai template sama lah.
Kita bincang pasal eksperimen. Nak buat eksperimen, nak buat macam mana kan?
Sebab nanti video
Nanti kita bagi tugas buat apa. Apa tu? Barang nanti kita bincang malam ni, lepas tu esoknya barang kita beli kan? Kita bincang macam mana. Barang ada dekat assignment tu, dia tulis T-collector apa dah. Kita bincang luar nak buat macam mana eksperimen dia.
Dia ada kena ada stopwatch pipe lagi.
Tu yang kita perlu. Macam satu tu pakai pipe kan, nak buat. Kita nak ukur dia punya ketinggian air kan. Satu pipe ke? Lepas tu apa yang dia nak, kita kena kira flow rate, velocity dengan number kan. Number bukan lah. Tu flow rate dengan velocity je kan.
Flow rate dengan velocity. Lagi kena ada random number. Kena cari.
Kena ada sekali kan.
Okay,
sekarang kita move ke task 2A tak. 2A ni sama je macam task 1 kan. Cuma kita kena tebuk lubang, 5 lubang.
Lepas tu mana tu dah off.
Diameter dia kena sama lah setiap lubang tu dengan jarak lah.
Bagi tugas lah satu.
Tu kita kira berapa air kita dapat dalam berapa saat kan. Data dia. Berapa milimeter kita dapat tu dengan berapa saat. Okay, so task 2B lah. Dia sama je macam 2A, cuma kita tambah 5 lubang lagi. So wayar dia makin panjang lah.
10 lubang lah.
10 lubang. Tambah 1 lubang lagi. Kita pakai yang T-connector tu. Data sama macam 2A kan.
Bukan cari kat Shopee
Kita orang cari kat ni lah. Hardware.
Hello?
Hello. Yo. Dengar kan?
Dah beli kan?
Dah esok kita orang beli. Dekat hardware.
Esok. Ya.
Lepas tu yang 2B tu sama je kan, data macam 2A dia nak kan. Masa dengan berapa air kan dia nak kan.
Ya.
Lepas tu kalau kita tengok kan, test pad tu kena pakai simulation kan, nak kira.
Siapa nak download yang simulation tu? App dia.
Dah download lah. Nanti malam nanti aku buat. Tengah malam ni. Kita just buat sekali lah. Nanti yang simulation tu just kita ambil gambar dengan nilai je kan. Lepas tu kita letak bagi tahu apa yang dia nak dengan nilai yang kita dapat. Pagi ya? Ada lagi korang nak tambah?
Kita buat macam kita buat cacat.
Design tu macam mana nak buat?
Apa? Oh, slide. Slide tu kita bincang meeting kedua nanti.
Design projek tu macam mana?
Result project.
Design projek.
Design. Kita ikut gambar macam dalam assignment dah bagi tu.
Okay.
Kita ikut
Boleh je.
gambar.
Nanti part calculation Vishnu buat
Ya, saya buat. Betul.
Okay. Tu je lah aku rasa kan malam ni.
Cukup lah. Dah ada cukup punya.
Okay. Assalamualaikum. Ini kita buat meeting yang kedua Okay, hari tu aku dengan Nazik dah keluar pergi beli barang itu. So kiranya esok kita akan run eksperimennya sebab itu aku dengan Nazik baru tengah cari barang itu. Baru jumpa kat awal. Lepas tu bila dah buat eksperimen nanti aku bagi data dekat Vishnu kan sebab Vishnu buat kira-kira kan.
Ya, okey boleh.
Okay, untuk malam ni apa?
Nak buat kat mana eksperimen?
Buat dekat ni bawah blok tu lah. Ada pipe kat sebelah tu.
Okey. Okey lah kan.
Okay, untuk malam ni kita buat agihan untuk slide dengan video presentation Okay. Malam ni malam ni lah untuk slide Aziz akan buat bahagian intro, objektif dengan group of member. Kau terangkan part tu dengan minute meeting Nanti dalam video kau terangkan 4 benda tu
Okay, boleh.
Okay, untuk Vishnu pula you akan terang pasal calculation
Yep.
Okay, untuk saya pula aku akan terangkan part run eksperimen dengan simulation. Okay, untuk call pula bahagian kau buat discussion dengan conclusion. Nanti kita terangkan part kita masing-masing.
Okay, boleh.
So nanti
Kalau boleh.
yang edit video siapa?
Apa?
Yang edit video siapa?
Di video aku.
Okay, boleh.
Kalau boleh slide tu aku nak hari Ahad malam lah kalau boleh
Boleh. Sehari sebelum saya hantar.
Apa?
Video berapa minit tadi?
Video kita maksimum 15 minit.
Minimum 10 minit
10 ke 15 minit video total maksimum video. Bagi part kita aku rasa tak panjang sangat sebab part Vishnu dah panjang sebab kira-kira kan dia banyak kena terangkan. So part yang lain aku estimatekan 3 hingga 4 minit lah seorang.
Okay.
Kita nak tambah video recording meeting kita lagi ni. Tu lah rasa. Estimate 3 ke 4
Video
minit.
ini juga. Video kita meeting sekarang ni. Kena include juga.
Kena include sekali.
Oh, okey.
Yang lagi apa nak tambah? Yang video tu kalau boleh aku nak hari Isnin tengah malam
Video presentation tu
sebab saya rasa tu kita nak kena submit dah kan sebelum ke 5. Aku nak edit lagi Isnin tengah malam tu. So boleh lah tengah malam tu
Nanti video kena ambil macam yang slide tu kan, yang muka kita dekat mana? Kena
muka kecil kita ada kat kanan bucu bahagian slide tu. Kan background kita slide kan. Aku nak muka kecil kita kat kanan bawah kat top tu.
Okey lah kalau gitu.
Okay, aku rasa tu juga malam ni.
Esok.
Ada apa lagi nak tambah?
Tu je. Saya tu je.
Tu je Okay. Terima kasih.
Okay, this is our content. Consists introduction, mini meeting, objective, experiment, calculation, simulation, discussion, and last is conclusion. Alright, as we can see, this is our mini meeting. The first meeting was held on 8 December 2021 at 8 p.m. until 10 p.m. Via Google Meet. Alright, we go to the next slide. This is our second meeting was held on December 10, 2021 at 8 p.m. until 10 p.m. We use Google Meet as a medium for this meeting. Alright, we go to the introduction. As we know, fertigation is a widely used for farming practice. Fertigation is a most efficient method that reduce input and deliver nutrient to the root zone. Fertigation is a one way of growing vegetable with advantage of minimizing amount of watering. They are also have two type of pipe configuration, may be applicable for the watering process, namely straight line or closed loop. They are also have two different configuration will give variation in terms of flow rate as well as the volume of water received by each plant. This situation will affect the quality of the plant. Alright, next we go to the objective. Our objective for this experiment is to perform experimental and simulation flow exercise in hosepipe. Second is to analyze pressure variation in hosepipe over a specific pipe length with two different configuration. And last but not least is report the finding in an appropriate approach.
Assalamualaikum and hi to everyone. My name is Muhammad Hazim Ahmad Hazman from BMMM 1/1. My number metric is B0920101111. Today, I would like to explain about experiment 1, which is task 1. First, we need to conduct experiment to measure maximum flow rate and velocity from a hose pipe. Second, we need to calculate maximum pressure in pipe based on Bernoulli equation. 3, we need to assume the system is frictionless. Okay, this is a picture from the experiment. The data we get is flow rate 0.0002 meter cube per second and the velocity 9.942 meter per second. And the pressure we get 6915.40 Pascal. Okay, next, experiment 2A. First, we need to set up hose pipe for task 2A. Second, use single connector to fit minimum of 5 holes at equal distance. Third, we need to block the end pipe. 4, ensure the whole pipe on the same level. 5, open the tap to maximum and measure velocity and flow rate each hole. Okay, this is a picture for task 2A. The data we get is water 45 mm and the time 37 seconds. Next, experiment 2B. First, we need to set up hose pipe for task 2B. Second, we use T connector to make it closed loop. 3, ensure the whole pipe on the same level. 4, open tap up to maximum and measure the flow rate, velocity at each hole all in once over the same period. Record data properly. Okay, this is a picture for the task 2B. Data we get is water 35 mm and the time is 33 seconds.
I am Sri Vishnu Jaisilan. I am going to talk about our calculation in this experiment. For our simulation, we get the pipe diameter 16 mm. We need to convert the millimeter to meter, so we get 0.016 meter. For the area of the pipe, we get 2.0106 times 10 power of negative 4 meter square. And for the water collector, we get 2 liters. We need to convert the liter to meter cube for our calculation. As per that, we get 2 times 10 power of negative 3 meter cube. And for the water for our flow rate, the water pipe must need to open to maximum to collect the water. Then we get the 2 liters. For the time taken, we get 10 seconds. And for the height of the water we reached was 1.8 meter. For the atmospheric pressure, we get 101.325 Pascal. For the dynamic viscosity of water, we get 8.9 times 10 power of negative 4 Pascal second. For the density of water, we get 996.7215 kilogram per meter cube. For the flow rate, we need to use the equation volume divide times. So the volume we know 2 liter, then we convert it to meter cube. As per you see, the 2 times 10 power of negative 3 and divided by 10 the second. So we get the answer 2 times 10 power of negative 4 meter cube per second. And for the velocity, we need to use the equation Q per A. Q is flow rate and A is area. So the flow rate is 2 times 10 power of negative 4 as per we get here, and the area 2.0106 times 10 power of negative 4. For this answer, the velocity is 9.947 meter per second. And this data and some of the data, we can calculate the pressure for this experiment. And for that, we need to use the Bernoulli equation. For the Bernoulli equation, pressure divided by rho g plus velocity power of 2 divided by 2g equals to pressure 2 divided by rho g and plus z2. The z2 is the height of the water we reached. As per we get the 1.8 meter. And for this, as you can see, we input the velocity 9.947 power of 2 and per 2 times the gravity is 9.81. We get negative 5.043, and we need to get the pressure, so we get it here, and after this we get negative 3.243, and here after we get the results of this 996.7215 times with 9.81 as per the rho and gravity, we get the answer negative 31709.528. If you wonder how we can get this, the 996.7215, it is the density of water. So after we get this, we need to take it here. The pressure of atmosphere is 101325, and after this calculation we get 69615.47 Pascal for the pressure. For the Reynolds number, we get the equation rho times with velocity and times with the diameter per U. The U is the dynamic viscosity of water, which is 8.9 times 10 power of negative 4 Pascal second. So we input all the data correctly and we get the Reynolds number, which is 178,234.593. And for all these calculations, we get the answers for the flow rate, velocity, pressure, and a Reynolds number. Flow rate is 2 times 10 power of negative 4 meter cube per second. The velocity is 9.947 meter per second, and the pressure is 69615.47 Pascal, and the Reynolds number is 178,234.593.
Okay, now I would like to explain about simulation for T-pipe. Okay, what we need to find from this simulation, which is T-pipe. Okay, first, we get pressure inlet, which is negative 2691.989 Pascal. This value we get when we do the simulation. Okay, next, we get the pressure outlet, which is 0 Pascal. Okay, next, we need to find the velocity. Okay, what we get this velocity inlet, which is 3 meter per second from this simulation. The value of density inlet, which is 998.2 kilogram per meter cube. For the density outlet, we get the same value, which is 998.2 kilogram per meter cube for this simulation. Okay, now we need to find viscosity. Okay, for the viscosity inlet, we get the value, which is 0.00100 kilogram per meter second. For the viscosity outlet, we get the same value, which is 0.00100 kilogram per meter second. The value is same for this simulation. Okay, the last value we need to find for this simulation for T-pipe is mesh. Okay, for the mesh inlet, the value is 0.0013 meter, and the value of mesh outlet, which is 0.0012 meter. The different inlet and outlet is a little bit, and it's quite same. So this all for the simulation for T-pipe. Now, I would like to explain about simulation for L-pipe. For the L-pipe, we need to find the value of pressure, the value of pressure inlet, which is 35,823.54 Pascal, and the value of pressure outlet, which is 0 Pascal. The value we get from this simulation, and we run it. Okay, next we need to find the value of velocity. From this simulation, we get the value of velocity, which is 6 meter per second. Okay, next we need to find the value of density. The value for density inlet, we get the 998.2 kilogram per meter cube. For the density outlet, we get the same value, which is 998.2 kilogram per meter cube. The value is same for the simulation. Next, we need to find the value of viscosity. For the value of viscosity inlet, we get the value, which is 0.001003 kilogram per meter second. And the value of viscosity outlet, we get the same, which is 0.001003 kilogram per meter second. The value is same for the simulation. Okay, last but not least, from this simulation for L-pipe, we need to find the mesh. So the value of mesh inlet, we get 0.00478 meter, and the value for mesh outlet, we get 0.00479 meter. The value is quite same and a little bit different. So this is all the value we get from this simulation. So that's all for me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum. So my name is Muhammad Suhaimi. And then I would like to continue my previous friend. So I would like to explain about discussion from our assignment, which is from the result we can know the flow rate water, which is increased during the time taken for water to fill up the jug will decrease. And then after that, it also can be defined that is the water flow rate is increased, and then it will take less time to fill the jug. However, the area of the pipe connector decrease in experiment 1 and 2, so the water flow rate also decrease. And then the last one, which is due to energy loss, which is minor and major loss. So we can see the result will decrease rate in effectively and pressure flow rate of the fluid. Okay, after that we go about the conclusion from the experiment, which is from the conclusion from the experiment we can get the simulation have been proved to apply the concept of Bernoulli equation and the usage of Reynolds number, which is used to determine whether a fluid flow is laminar or turbulent. Okay, after that, from observation from our group, which is the fluid flow with the ANSYS software, we were able to find out several specific variable, such as example viscosity and mesh. So we get to know the fluid motion that was generated. And then lastly, we can conclude the experiment was accomplished and the work has performed successfully. Okay, so thank you for watching.